All right, this is lesson 20, graphing linear equations. All right, concepts. There are multiple ways to graph and represent graphs of linear equations. As such, there are three forms of linear equations: common formulas that represent linear functions or are needed to find the slope of a line are included on your reference sheet and are listed below. So you have the slope, which is given 2 points, x1, y1, and x2, y2. Gives you m equals y2 minus y1 over x2 minus x1. We learned that in the last lesson. Standard form, ax plus by equals c, where a, b, and c are constants. Slope-intercept form, which is the most common, y equals mx plus b, where m is the slope and b is the y-intercept. And then you also have point-slope form, given x1, y1, and m, y minus y1 equals m times x minus x1. All right, test-taking tip. There are several important things to remember when graphing linear equations. Formulas for the different forms of linear equations are often provided on standardized tests. When graphing a line, it's important to neatly extend the line to the edges of the coordinate plane. If you do not have a ruler or you are not permitted to use one, you can use the edge of the test booklet or sheet of paper to draw your lines. Any equation that can be solved for y, it can then be graphed by choosing values for x and substituting the values into the equation to find the values of y. Solving for y means that everything other than y is moved to one side of the equation and y remains on the other side. And then when in doubt, solve the equation for y and use a table or point-slope form to graph the equation. All right, slope-intercept form. The slope-intercept form is one of three different types of linear equations. As the name states, the equation gives us the slope of the line, denoted by m, and the y-intercept b. Because this form is so easy to identify and simple to graph, this form is readily used to make quick graphs of linear functions. This is the easiest form of a linear function to graph when the y-intercept is visible on the graph. Example 1, graph the equation y equals 3x minus 5. Step 1, locate the y-intercept in the equation. So the y-intercept is -5. Okay, so I plot the point on the x-axis 0, -5, right there. Okay. Locate the slope, it's right here, which is 3 or 3 over 1. This tells me I need to go up 3 and over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. Okay, from my original point, up 3 over 1. So recall that the slope is rise over run. For the point in step 1, I count up or down. I can go down. So -3, one that's off the edge. Okay. It's also possible to graph the equation in the example above by creating a table of values and plotting the points. It is important that you use at least 3 points for a line. If the points do not make a line, then there is an error in your work. The table for y equals 3x minus 5 is shown below. So I pick values for x, so -1, 1, 0, 2, 3, and then values for y are these values right here. Standard form. Standard form is the only form that does not allow us to graph a linear equation quickly. This form can be graphed by finding the x-intercept and y-intercept. Standard form does, however, give us a way to neatly write a linear equation using whole numbers. So example 2, find the x-intercept and y-intercept of the equation 2x plus 4y equals 12, then graph the equation. So step 1, I calculate the x-intercept by substituting 0 for y, which gives me x equals 6. So the x-intercept is 6, 0. Then I calculate the y-intercept by substituting 0 in for x, which gives me y equals 3. So the y-intercept is 0, 3. I then plot those 2 points and then draw a line. Okay. It's also possible to rewrite an equation written in standard form as an equation in slope-intercept form by solving the equation for y. This would allow us to graph the equation just like we did in example 1. Okay. Then you have point-slope form. The point-slope form of a linear equation is another simple way to graph a line. In order to use this form, you need to know at least one point and the slope. The point-slope form allows us to use any point on the line. For a point x1, y1 and the slope m, the equation is y minus y1 equals m times x minus x1. So I want to write an equation given the point 2, 4 and a slope of 3. So I substitute in my values. 2 goes in for x1, 4 goes in for y1, and 3 goes in for my slope. So I get y minus 4 equals 3 times x minus 2. So this is my solution to my equation. Example 4, write an equation that passes through the given points 2, 5, and 8, 4. So the first thing I need to do is find the slope. When I do that, I get negative 1/6. Then I substitute that in to my point slope form and solve. So I get y minus 5 equals negative 1/6 x minus 2. For example 5, I want to rewrite the equation y minus 4 equals negative 2 x minus 5 in slope-intercept form. So the first thing that I need to do is I need to distribute this negative 2. When I do that, I get negative 2x plus 10. I'm going to add 4 to both sides, and then 10 plus 4 is 14. So this is my slope formula. For example 6, I want to graph the equation y minus 2 equals 3 times x plus 1. I locate the point in the equation. The x value of the point is negative 1, and the y value of the coordinate is plus 2. As noted in the equation, note the sign of the coordinate is opposite of the sign of the equation. So point negative 1, 2, place the point on the coordinate plane. Then I located the slope, which is 3 or 3/1. So again, I go up 3/1, up 3/1, or down 3/1, down 3/1 to get my graph. Write equations from graphs of linear functions. Occasionally, it's necessary to write an equation by looking at a graph. This is an essential skill that is used on many of the exams, including the Keystone. There are 2 forms of linear equations that are useful in writing an equation from a graph, depending on what you can see on the graph. So you have slope-intercept form. The y-intercept is visible. I locate the y-intercept and count the slope. Or point-slope form. The y-intercept is not visible. I locate one point and I count the slope. So example 7, write the equation of the line for the graph. I locate the y-intercept, which is right here, which is b equals 3, and then I count the slope. I go to the left, I go up to the left, I go down 1 and over 2, down 1 over 2, down 1 over 2, or up 1 over 2, up 1 over 2. So that gives me my slope of m equals negative 1/2. I substitute the values of b and m into the formula, so I get y equals negative 1/2 x plus 3. Example 8, write the equation of the line from the graph. Since the y-intercept is not visible on the graph, use the point-slope form of a linear equation. I locate one point, any point on the graph, and I create a dot. Okay? So I use negative 3, 0. I count the slope m on the graph to the square. So I want 1, 2, 3, 4, 5 up, 1 over, which gives me a slope of 5. And I substitute that into my formula. Y minus 0 equals 5 times x minus a negative 3, or x plus 3. This equation can be written in slope-intercept form by distributing the 5. So I get y equals 5x plus 15. All right, that is the end of lesson 20, so go ahead and work on the exercises below.